All right, this video is going to talk about how to graph a tangent and a cotangent. So first of all, let's get the basic sort of shape of our graph down. And then we'll go ahead and relate it to, how do we find the major parts. Now, one of the major things that you want to find is definitely the period. Realize for the period of the tangent and the cotangent, this is unlike all of the other trig functions. The other trig functions, typically it's 2 pi, or 2 pi divided by b, 2 pi divided by whatever you're multiplied by inside of your trig function. For the tangent and the cotangent, you'll notice over here at the left, the period is actually just pi over b. And the reason for that is this. For the tangent, notice that again, we're the sine divided by the cosine. We know that formula. Well, if we're dividing by the cosine, the first couple of places that the cosine would have been equal to 0 would have been at pi over 2, or negative pi over 2, or possibly 3 pi over 2. Well, that means that if we're dividing by the cosine, the first places that the tangent does not exist are at negative pi over 2, pi over 2, and 3 pi over 2. Okay? So again, we have asymptotes there, much like the other reciprocal functions. The difference now is, well, anywhere that the sine would have been 0, right? The top of our fraction would have been 0. We're still going to be at 0. And in between there, we'll realize that the tangent at pi over 4, right, in between our 0 and our pi over 2, tangent at pi over 4 is actually equal to 1. And so is the tangent of negative pi over 4. So the graph we actually get is actually a line following the asymptote up sort of through those points and curving up. It almost looks like a cubic function. Again, we're going to be negative 1 and positive 1. And again, we're going to curve up and away. If you actually check out the values, again, at those sort of quarter marks, if you will, right? Pi over 4, 3 pi over 4, 5 pi over 4, we're going to get positive and negative 1 values. All right, those 45-degree angles, think of it that way. Tangent at 45 degrees is always 1, and the tangent of any reference angle at 45 degrees is either going to be 1 or negative 1. And that would be the reason why, again, this same curve, that same S-curve happens in between the asymptotes, right, happening. But notice, I don't need to go a full 2 pi units to complete one cycle of the tangent, right? One cycle is just one of these curves. Then it repeats itself. That's the idea of the period, right? How long does it take before it repeats its own pattern? Whereas with the sine and the cosine, it took a full 2 pi, right, to go up and then go down and come back. The tangent completes one full cycle, right, one full S-curve in between every asymptote. So again, it's just pi units left to right. Realize the cotangent's kind of the same idea. The difference is now we're dividing by the sine. So again, the first asymptotes are going to happen at 0. They're going to happen at pi. And again, the third one would happen at 2 pi, right, where the sine would have been 0. Where the cosine was 0, we would be, going to have a 0 value. So again, halfway between the asymptotes, we're still on the axis. And again, at every 45 degrees, now this is tricky because at positive pi over 4, or positive 45 degrees, the cotangent actually is positive. At 3 pi over 4, right, that second quadrant, the cosine would have been negative. And then the same thing happens again. At 5 pi over 4, we would have been back to positive. And then we're back to negative. So actually, the cotangent curve looks a lot like the tangent, only we're going to start high and kind of go low on this one. You start at the upper portion of the graph, again, and work our way down. But again, period's still just pi over b. Let's take a look. Again, simple values for this. We're going to go kind of quickly here. Again, anywhere the sine would have been 0. So for the cotangent, where we're dividing by the sine, as we just talked about, basically the asymptotes are going to happen at multiples of pi. So at 0, at 1 pi, 2 pi, 3 pi, 4 pi, right? Or basically if we shift that stuff around, anything we do to anything horizontally, right? Those are all x equals. So any of the horizontal shifts, anything happening inside of our cotangent, we're going to be at 0 and pi unless we change the period or we do a phase shift, right? If we change B and C, we're going to change things horizontally. Same idea for the tangent. Again, anywhere the cosine would have been 0, we get asymptotes. So that's why we're going to get those at pi over 2. And again, plus pi n, right? Every pi units down the road. And again, that also shifts or stretches according to the horizontal changes. One last thing to remember, again, as we noted earlier, the period of the tangent and the cotangent is different than everything else. It's going to be pi units on there. So let's take a look. Let's graph one of these. Take a look at what happens to the tangent when a few other things are happening in here. 3 times the tangent of 1/2 x plus 2. Now, the first thing I want to try to figure out, again, it's helpful to have those vertical asymptotes. Again, you could find the period first if you wanted to. In fact, I could go down here and just kind of do that. Remember that the period is going to be pi divided by b. Well, remember, b is what's multiplied inside of our function. So pi divided by 1/2, our period will actually end up being 2 pi here. That's a little counterintuitive as I just keep telling you it's pi units. But again, we're stretched, right? We're horizontally stretched. If you divide inside by 2 or multiply by 1/2, that's horizontally going to stretch things apart here. Vertical asymptotes, again, the easiest way to do it is just take 1/2 x then, and let's set it equal to, well, again, because the tangent is usually equal to sine over cosine. Cosine was normally 0 at negative or positive pi over 2. If I divide by 1/2 or I multiply both sides by 2, basically we're going to get asymptotes at negative pi and pi, which would make sense because, again, if we go to negative pi right here and pi units, right, make them symmetrical or as close as we can anyway, over here, well, those are 2 pi units apart, right? Again, we said that period, right here, was going to be 2 pi units apart. 1 full period between every asymptote. Then let's find ourselves some helpful points. Again, you'll notice we're shifted up 2 units. So again, I'm going to make my equilibrium, or sort of my new x-axis, if you will, be shifted up 2 units, which means that's exactly halfway in between the asymptotes, right on the y-axis there. Right? The tangent of 0 is 0. So again, right now, the tangent at 0 is going to be up at 2, right? Halfway in between the asymptotes, right on the equilibrium. And then that helpful 3 out in front, those are sort of our quarter marks. So right now, where we would be at pi over 2, right? At pi over 2 units, if we wanted to sort of list those off at all, we're going to be up 3 units and down 3 units. So again, from equilibrium, 1, 2, 3, I'm going to be up here. And from equilibrium down 1, 2, 3, okay, we're going to be right down there. And the tangent starts low and goes high, right? And goes up that way. If we wanted to draw a little bit extra, wanted to put a second phase on there at all, again, we just want to remember there's essentially 4 tick marks here, right? From one asymptote to the next. So I'm going to go ahead and put 1, 2, 3, 4. This is going to be my next asymptote. Again, we're going to graph our line right on the equilibrium. And again, we're going to go up 3 units, down 3 units, right, in between those. And try to make them look, like I said, somewhat cubic, right? Sort of like that S curve, following the asymptote on the left, curving up through our 3 given points, or 3 easy to find points, over to that next asymptote and continue to rise. Again, I hope that helps you with tangent graphs and cotangent graphs. If you have any questions, talk to your teacher. Otherwise, have a great day.